In this session we shall see the modeling of a block-type machine foundation by using 3D solid brick elements and the dynamic analysis of the block model for eigenvalue analysis. We shall analyze two models. In the first model we shall see the analysis results for displacements, and in the second model we shall increase the size of the block model by resizing with application of factors to increase the mass of the model and see the reduction in displacements. This helps in deciding the size of the structure to control the vibrations created by the operation machine installed on the block foundation. The size and the translation movements in vibration of the foundation will also indicate to decide the foundation to construct as an embedded or a surface structure. The main screen of Astra Pro is open. First we select the menu item file, then select working folder, and as the dialog box comes select folder work on the desktop. Click on OK. Next, select menu item file, then structural analysis. This will open the analysis workspace. The current tab is Create Project and input data type is text data. Add new analysis. The project name is shown as Design Job Number 1. Click on button Create Project. The project folder is created as Design Job Number 1 inside folder Structural Analysis, which is further inside the working folder work. The message comes confirming about creating the project folder and click on OK. Next, select the tab Modeling at the top of the workspace, and inside further select the tab 3D Structure Modeling. Under this tab there are some other tabs. The current tab is Joints. Click on button Add at the bottom. The dialog box comes. Type the values for X, Y, and Z for the start joint, and click on the button Add Joint. The joint number and its X, Y, and Z coordinates are listed on the left side panel of the window. In similar way type the X, Y, and Z coordinates of all the joints for the block structure, and every time click on button Add Joint to enter in the list on the left panel. At the end click on button Close to finish the data entry for all 166 joints for the model. Next, select tab 3D Brick Elements and click on button Select 8 nodes. The dialog box comes with the list of all the joints of the structure. Select 8 nodes of a brick element by check marks on joint numbers, first for the 4 joints counterclockwise of the upper face and then for the 4 joints counterclockwise of the lower face. Click on button OK. The brick element with all its 8 nodes will appear in the list on the left panel of the window. Once again click on button Select 8 nodes. The dialog box comes with joint numbers and select 8 nodes for the next brick element. Once the job is completed for all the 66 brick elements, click on button Save Data, and as the dialog box comes we type a file name as in bricks and click on button Save. The data is saved in file in bricks.txt. In multi-session work, user may close the analysis workspace after saving the data, and in next session the data may be opened in by using button Browse under New Analysis in the first tab page. Create project, continue the work for modeling. Next, we open the tab page Process Analysis and click on button View Pre-Process. This opens the graphic user interface GUI for entering various data for the analysis of the model structure. The GUI window opens. Select Tab Properties. We click on button Add, the dialog box comes, we enter various material properties in the boxes. Click on button Add and then close. Next, we open tab Page Supports. We click on button Add, the dialog box comes, we enter various joint numbers in the boxes, select support type. Click on button Add Data and then Finish. The supports will appear in the list on the left panel of the window. Next, we open tab Page Loading. Under Define Load Case we click on button Add, the dialog box comes, the load case number and the load type are entered in the boxes, click on button Add Load Case. Next, under Define Load we select Joint Load, we click on button Add, the dialog box comes, the joint numbers and the applied joint loads are entered in the boxes. Click on button Add Load. In the similar way we add all joint loads, and as it is complete we click on button Close. Next, Once again under Define Load Case we click on button Add, the dialog box comes, the load case number and the load type are entered in the boxes, click on button Add Load Case. The load case 2 is created in the left panel of the window, select the load case 2 by clicking on it. Next, under Define Load, we select brick load, click on button Add, the dialog box comes, the brick element numbers and the applied pressure are entered in the boxes. The negative sign is indicating the direction of the applied pressure. Click on button Add Load. The brick load is listed in the left panel of the window, we click on button Close. Next, we open tab Page Dynamic Analysis, place check mark in the box for Dynamic Analysis, the item selected as Perform Eigen Values Analysis, the number of frequencies is shown as 3, and we accept the default values. Next, we select the first tab data file in the GUI window, we click on button Save Data File, the data file is saved and the message comes. We can see the full analysis data on the left panel of the window. After viewing the whole data we close the GUI window. Next, we are once again back to the Analysis workspace, we click on button Process Analysis, the data validation dialog box comes, we click on Proceed, as the data validation is done the message comes we click on OK, next the Process dialog box comes, we click on button Proceed to start the analysis for the data we created. As the analysis is over the message comes mentioning about the analysis report, we click on button OK. The analysis report is displayed on the workspace screen. We can see the results and the analysis report can also be opened in Notepad for taking printout. Next, we close the analysis workspace as the first analysis is over. From the main screen of Astra Pro we once again select Menu Item File, then Structural Analysis, this will open the analysis workspace. The current tab is Create Project and input data type is text data. At New Analysis, the project name is shown as Design Job Number 2, click on button Create Project. The project folder is created as Design Job Number 2 inside folder Structural Analysis, which is further inside the working folder Work. The message comes confirming about creating the project folder and click on OK. We select the file in bricks.txt inside the last project folder Design Job Number 1 of the last analysis, by using button Browse under New Analysis in the tab page Create Project. A copy of file in bricks.txt from last project folder Design Job Number 1 will be brought to the current project folder Design Job Number 2. Next, we select tab Process Analysis, and click on button View Pre-Process. This opens the GUI window by displaying the last model with the analysis data. We select the tab Geometry, and enter the values for X factor, Y factor and Z factor as desired under Resizing Structure and click on button Apply. As the factors are applied, the previous X, Y, and Z coordinates are changed and the structure is modified. By keeping all other data unchanged, we come back to tab Page Data File and save the modified analysis input data file in Project Folder Design Job Number 2, by clicking on button Save Data File. We close the GUI window and come back to Analysis Workspace. Next, we click on button Process Analysis. The data validation dialog box comes. We click on Proceed. As the data validation is done, the message comes. We click on OK. Next, the process dialog box comes. We click on button Proceed to start the analysis for the data we created. As the analysis is over, the message comes mentioning about the analysis report. We click on button OK. The analysis report is displayed on the Workspace screen. We can see the results, and the analysis report can also be opened in Notepad for taking printout. We open the analysis report files from Project Folder Design Job Number 1 and from Folder Design Job Number 2, and we can compare the effects of resizing of the structure on the analysis results. Other similar trials can be done by various resizing of the model, to decide the final size of the block structure for the machine foundation by controlling the effect of vibration by reducing the translational displacements by the same applied dynamic forces. Finally, we close the analysis workspace, and this is the end of the current session, on dynamic analysis of block type machine foundation with model by three-dimensional solid brick elements. We hope you enjoyed the video session, and we thank you for watching the tutorial video.